the number of protons and the number of electrons will always equal. And basically, well, this applies for singular atoms. Um, Basically, you would have so say there were like 5 protons, so you get a +5 charge. You would have then 5 electrons, you get -5 charge, and they cancel each other out into 0. And in physics, if there's 0 force, then the like speed between the moving at each other stay the same, so they will keep in each other's distance around the same. Basically, you just need to know they cancel each other out, so the atom has a neutral charge. So atoms have a neutral charge, and that's all you need to know. Next, we can talk about how in the periodic table you would have the atomic mass and the atomic number. So if we rub all of this out, no. If we try and rub all of this out, let's rub it all out. Just go back to the video. Go back a few minutes if you haven't copied that down or anything. If we say so, atomic mass. It's called relative atomic mass, I think, and atomic number. Right, what you need to know is atomic mass is the mass of the protons and neutrons, or the number of protons and neutrons in an atom. That's simple enough. So in hydrogen, the atomic number is 1. Sorry. Yeah. Sorry, the atomic mass is 1. Actually, yeah. That's a terrible thing. Let's go to right. In hydrogen, the atomic mass will be 1 because hydrogen doesn't have a neutron, and without a neutron, there's only 1 proton, so you have an atomic mass of 1. The atomic number as well in hydrogen. Now let's explain what atomic number is first. It's the number of protons. So in hydrogen, there's only 1 proton, so atomic number is 1 as well. Now, you can also calculate the atomic mass when you're given the number of electrons, because if you say you're given the number of neutrons but not the protons, but you're given the electron, you know that number of protons is equal to the number of electrons, so you can work it out like that. So the main point here is the atomic mass is the mass of the protons and the neutrons, sorry, not meant to be neutrals. Neutrons together, and that's meant to be a and the atomic number is the number of protons. And as we have said before, the elements in the periodic table are arranged in order of their atomic number, because atomic mass can always change. You can have an hydrogen with different atomic masses, or you can have well, theoretically you can have elements of different masses, because protons, the number of neutrons can change, and they're called isotopes, but you don't need to know about them yet. But I think that sums it all up. You just need to be able to calculate the number of the atomic mass. So let's have a question here. Question 1. An atom has 40 electrons and 15 neutrons. What is the atomic mass? Well, let's do the working out. N stands for number of, no, that's, P is the number of protons, and you know that is equal to the number of E. That's the number of electrons. Now, because you know P equals E, and E is 40, you know that P is 40. Now, you know that the atomic mass, M, is equal to N, neutrons, plus P. And because P is 40 and N is 50, M equals 15 plus 40 at mass. The mass is equal to 55. So the atomic mass there would be 55. So that's how you work it out. I don't think it should be that hard. It's quite simple, and you just need to practice and all that. So let's go over the keywords. The keywords of this these two lessons, they are, okay, we have to rub it all out again, which is always good, but time wasting, but we've got time. So the keywords are, let me type it all up. We've got element, no, we want that in a different colour, don't we? Element, pink. No, element, atom, group, nucleus, electron, compound, proton, proton, no, proton, neutron, atomic number, and mass number, or atomic mass. Atomic mass. Now, before we go over them again, if you like, you can pause the video right now, get a piece of paper, and try to like get your own definitions. But you can pause it right now, and then so we're now going to do it. I assume you paused it. We're now going to just make our own definitions according to the exam board. Anyway, element, we can say it's the building blocks of everything. So a substance which contains only one type of atom, and that's true because everything is made of atoms and elements are the building blocks of matter, and so an element is a substance which contains only one type of atom. An atom is the building blocks of everything, and yeah, I think that's all you need to know about an atom. Yep. Sorry about the awkward pause. A group is a column in the periodic table, and we need to know that it has similar properties and same number of electrons on the outer shell. So elements in the same group have similar properties and have the same number of electrons on the outer shell. Now we go to the as well as that, actually, let's go for period. Period is actually quite simple. A row in the periodic table, and they have same number of electron shells, and I'm quite sure you can look it up, but I'm quite sure they the lower down you go, go in the periodic table, the lower down you go in the periodic table, the more reactive elements substances get. Next we have the nucleus, and nucleus is like the the inner part of an atom, contains proton and neutron. The electron orbits the neutron, has a negative charge, and also almost no mass. And then compound is, oh, we haven't been through compounds, have we? Compounds are when atoms chemically bond together. So a compound is a substance, oh sorry about that guys, a substance which contains more than one type of atom chemically bonded together. That's all you need to know. We'll go more in the depth with compounds later, but that's all you need to know for now. Protons makes up the nucleus, positive charge and mass of 1. And then a neutron makes up the nucleus. So protons and neutrons makes up the together make up the nucleus, and neutron, as it suggests, has a neutral charge, neutral or no charge, and mass of 1. Atomic number is the number of protons in the atom, and then atomic mass is the the total mass or total amount of protons and neutrons in a atom. And that's the keywords done. This video has been quite long. I'm trying to keep them short, but we have quite a lot of stuff to go through. And just one thing to help you remember, like the ways protons and neutrons go around, or like whether they're positive or negative. Oh wait, protons and electrons. Think about this, okay? Teachers always want students to be protons. Remember that. Because protons are bad. No, they're not bad. They are positive. Whereas the electrons get detentions because they are negative about everything and they don't want to learn. But that's all you guys need to know. I hope you found this useful. Tell me more, comment in the comments, tell me what you think. Do you think I explained things well? What could I do to improve? Do you think this should be structured better? And would you like it to be more fun? I'm trying to make it more fun-ish. But would you like more questions for you to solve? Would you like more parts where pause give you a question or something to do, like tell you to pause it, you do something and then you unpause it and the answer comes. Which, do you like those kind of stuff? Yeah, so this is a new series. It's basically revision. Helps me, helps you, and I hope you guys leave a like, comment, and subscribe for more tutorials and revision stuff. I do speed art, drawing tutorials, loads of other cool stuff. But this is the first episode of all of these things I'm doing, and I hope you guys stick around for that. But hope you do well in your GCSEs for those who are watching this to revise. But I guess it's time for me to say goodbye. See ya.